Hi guys, in this video we'll be taking a look at three stages of any Ansys analysis. Let us think about any Ansys analysis that you can do. It may be structural, thermal, CFD, modal, explicit dynamics, or any analysis that you do. We should follow three stages in order to get the results. So what are they? We can divide the three stages as pre-processing, post-processing and post-processing. So in the pre-processing stage, we will be creating the geometry either on Ansys or we'll be importing it from any other CAD software, and then we'll be creating a mesh around the geometry. So meshing is a process of discretization where you'll be breaking the whole solid or whole domain into many smaller elements. So this is actually done to reduce the degrees of freedom from infinite to finite, and that is why this is being called as finite element analysis or finite volume analysis, however it is going to be carried out. So we'll be taking a look at detailed look about meshing in the following videos, but for the time being, please understand that geometry creation, meshing and boundary condition are going to form the pre-processing stage. So what I mean by boundary condition is the boundary values of whatever parameter that we are going to look at. These boundary values can be forces, supports, temperatures, velocities, pressures, or anything in that order. But Ansys always needs a kind of start value, that is what are the parameters at the boundary. Let us assume that if it is a pipe flow, then what is the pressure and velocity at the inlet. If we can specify that, it will compute the pressure and velocity at the outlet. So these are actually called as the boundary conditions. Next is the processing stage. So this processing stage is actually what is being carried out by the solver. So what the solver actually does is, depending upon the boundary conditions that you are given, it will solve some governing equations. In during analysis, every analysis is actually governed by some set of governing equations. For example, the governing equations that I have written here is for a fluid flow. So these are called Navier-Stokes equations, and this is the continuity equation, and these are the momentum equations. We'll be taking a detailed look at this if you're going to take the CFD module with us. But for the time being, we just need to understand that the solver actually solves such complex equations and then it gives out the results. Once the solution has been done, we come to the post-processing stage. It is in this post-processing stage that the results are going to be converted in the form that we can understand, in the form of contours, streamlines, vectors, or whatever you want them. It can also be quantitative results. So results are actually two types, qualitative and quantitative. Qualitative will be in the form of image, in the form of a contour or a streamline or a vector, and quantitative will be in terms of numbers. So you will be given what is the force at some discrete point, what is the drag, or what is the lift at a particular point on your body, and things like that. So this is basically nothing but report generation. So you start with creating the geometry and meshing it, and then giving the boundary conditions, and then throwing it to the solver to solve the equations, and then you get the report. Okay, here is a typical example of the three stages. So this is actually a thermal analysis that was being carried out on a rotor, disc rotor, brake disc. And you can see that the geometry has been created. This geometry was originally created in SolidWorks and it was imported onto Ansys. Now you can see that I have performed a meshing operation over this geometry. So this whole geometry has been divided into number of smaller elements. So this is what is called as discretization, in a simpler term called as meshing. And then I could not show the processing stage here because that is what is going to run behind the computer. So that is what the solvers are actually going to do. And once the solutions have been generated, I can post-process them in the form of a temperature contour. Okay, now let us see a simple real-life example, an analogy to understand how pre-processing, processing and post-processing works. We have gone through this ordeal of being hungry at home, and what we actually do is, when you tell your mother that you are hungry, she says you go and bring the vegetables. So probably going to the shop and buying the vegetables and creating the things that you need to cook. So preparing the things that you need to cook as a pre-processing stage. So you go to the shop and you buy the vegetables, and this is what is similar to creating the geometry and meshing it. Then because you cannot cook, you leave the process of cooking to an expert, which is your mother, and she does the job of cooking. Same way, because we cannot solve the complex governing equations, we leave the job of solving it to the solver, and that is what the Ansys solvers actually do. FEM or FPM solvers actually do. So once it is done, your mother gives the cooked food to you and you post-process it in the form of eating, right? So this is what is the end stage. So once the results have been computed, it converts it into a form which we can actually interpret in the form of a contour, qualitative, or it can even be in the form of a numerical value, as in a force or a drag or a lift value, in the form of a quantitative number. So this is a simple analogy to understand pre-processing, processing and post-processing stages. Thanks for watching the video.